All right, so we're going to keep talking about lines, and we're going to talk about parallel lines, and even more specifically, we're going to talk about the slopes of lines and how they relate to parallel and perpendicular lines. But first, we're going to do a little refresher because we're going to spend a lot of time talking about the coordinate plane and slopes and rise and run and x's and y's. So just a quick refresher. If you remember from algebra, when we have a coordinate plane like this would be quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And what's important to remember is that in quadrant 1, the x and the y are positive. In quadrant 2, the x is negative and the y is positive. Quadrant 3, they're both negative. And in quadrant 4, the x is positive and the y is negative. So when we have a question like this that says, in which quadrant do the following coordinates lie? 4, negative 2, well, 1, 2, 3, 4. Negative 2 is right here, and that lies in quadrant 4. Now we can tell that without even using the graph because we see that it's positive, negative, and that's what quadrant 4, that's the pattern quadrant 4 follows. So if we look at B, it says negative 1, 5. Well, that's a negative, positive, that falls in quadrant 2. So even without the graph, we can find these. Another example, if x is greater than 0 and y is greater than 0. Well, that's a fancy math talk for saying x is positive and y is positive. What quadrant does the point x, y lie in? Well, it's positive, positive, so that's quadrant 1. Okay, just a quick refresher so you kind of have an idea of what we're talking about and where we're going. So the slope of a line in a coordinate plane is the number that describes the steepness of the line. Any 2 points can be used to determine the slope. So if you think about a line, it has an infinite number of points. We can use any 2 to find the slope. So in a coordinate plane, and this is a reminder or a refresher for you, the slope of a line is the ratio of the change along the y-axis to the change along the x-axis between any 2 points in the line. The slope, the letter we use for slope is m, so the slope of a line containing 2 points with coordinates x1, y1, and x2, y2, and that just means every point has an x and a y, so this is the first point, this is the second point. The slope is always the change in y over the change in x. And we may talk about that as the rise over the run. And in our formulas and the way you're going to write it a lot, we're going to write y2 minus y1 over x2 minus x1. And something else that you're going to see that I don't have a space for in your notes is a little triangle like this that means change in y over change in x. And that's just a Greek symbol, we say delta. So this is delta y over delta x. And that's just another way you might see the change in y over the change in x. So if you look over at this picture for a second, it just kind of reminds us of all these things. The slope is the rise over the run. Remember, we see the difference between the y values, y2 minus y1, and we see the difference between the x values, x2 minus x1. If we have a graph, we can just count the rise over the run and write our slope that way. So just reminders, just more of a refresher today. Okay, something that we need to be familiar with is when a line has a positive slope, a negative slope, zero slope, or an undefined slope. So these are kind of things you need to be able to just glance at and answer. So a positive slope looks like this. And remember, when we read a graph, we read from left to right. So starting down here, we're going from the left to the right. Our graph is increasing, so it's positive slope. Negative slope looks like this. The line will be going down from left to right. Zero slope looks like that. It's a horizontal line. And an undefined slope looks like this. It's a vertical line. And hopefully remember all that from Algebra 1. Now there's a little acronym that you may have learned to remember. This HOY or HOY says that for a horizontal line, it's going to have zero slope. That's what the O or the middle stands for. It's really a 0. And it's going to be a line or an equation that says y equals. A vertical line like this one, vertical, is going to have an undefined slope, and it's going to be x equals. So just keep that in mind as we're working. All right, so let's look over at the picture, and we're going to use the graph to determine the slope of each line. So we look at line AB. Well, it's AB, and if you can't look at it and tell, you can always figure out the rise over run. So if we look to go from A to B, the rise is how much do we go up? Well, we don't go up any, so we go up 0. And the run is how far do we go from A to B? So we go 1, 2, 3, 4, 5. So 0 over 5 equals 0. So the slope of line AB is a 0 slope. All right, now we look at line AC. So here's A, here's C. So we'll do the same thing. We'll figure out the rise over the run. So to go from A to C, how much do we go up or down? Well, it's down, and it's down 1, 2, 3, 4, 5. So we went down 5. That was our rise. So that's right here, down 5. And then we went over 1, 2, 3, 4, 5, 6. So our run is 6. So that's our slope, negative 5 over 6. And our last one, AD, use a different color here. AD goes from A to D. So our rise over run. So our rise is 1, 2, 3, 4, 5, 6. AD's down here. So we go down 6. Our run, how far from A to D, how far do we go left or right? Well, it's 0. We stay at the same spot. So it's over 0. And you know that you can't divide by 0, so that is an undefined slope. All right, we're going to talk real quickly about parallel and perpendicular lines. This is also probably a refresher for you, so go pretty quick. Two lines are parallel if and only if they have the same slope. So an example of that would be these two lines. So y equals 1/2 x plus 7 and y equals 1/2 x minus 3. So they both have, and you know from your equations of lines, when you have y equals mx plus b, the m is the slope. So they both have the same slope, so those are parallel lines. Two lines are perpendicular if and only if their slopes are called opposite reciprocals. I'll show you what that means. So if we have y equals 2 over 3x plus 1, the perpendicular line, or a perpendicular line to that, would be y equals negative 3 over 2x plus 4. Now the plus 4 and the 1 don't matter for our perpendicular part. What matters is that this number and this number are what's called opposite reciprocals. It means you flip over whatever the number is and you make it negative, or if it was negative you make it positive. So another example would be like y equals negative 4 over 5x plus 3, and the perpendicular to it would be y equals 5 over 4x minus 1. And again, the 3 and the 1 are irrelevant here. The number that we're looking at is this number and this number. So they're flipped over and you change the sign on them. All right, so we're going to look at a quick example of what you're going to have to do. So we have two lines, UV and XY, and the problem says use their slopes to determine whether the lines are parallel, perpendicular, or neither. So what you have to do is calculate the slope for each line. So we'll start with line UV. So for UV, we have the point U, which is 0, 2. We have the point V, which is negative 1, negative 1. So for this line, this will be x1, y1, x2, and y2. And to find the slope, we have to use the slope formula, which hopefully you remember is m equals y2 minus y1 over x2 minus x1. So when we plug our numbers into that, we have y2 minus y1 over x2 minus x1, which gives us negative 3 over negative 1, which ultimately equals 3 over 1. So our slope equals 3. And now we're going to look at line xy. And xy has the point x is 3 comma 1 and y is negative 3 comma 3. So for this line, x1 y1, x2 y2. So again, we're going to do the slope formula. So the slope equals y2 minus y1 over x2 minus x1. So that is y2 minus y1 over x2 minus x1. So 3 minus 1 is 2. Negative 3 minus 3 is negative 6. We can simplify that to negative 1 over 3. So this slope equals negative 1 over 3. And at first glance you might say, well, I don't know, those aren't the same, so they're not parallel, right? That would mean same. Perpendicular, you would have to flip them over and make one of them the opposite sign. But if you remember, 3 is really 3 over 1. So 3 over 1 is perpendicular to negative 1 over 3. And that's how we would write it. We'd write this little perpendicular symbol. It's like an upside down T. So these two lines are perpendicular. Okay, now I got a couple more examples. It says you try this one, so there's 2 more examples. So you give these a try and come into class tomorrow and we'll see how you did on them.